Good morning. I hope you all are having a fantastic day. I'm running a little bit behind getting the videos made, but by the time you get out of class today, this should be up and available for you to see. So today we're going to continue domain range. We're looking at continuous functions. So over here to the side, I want you to click on modules. And then we're going to scroll down all the way to the bottom, and we're doing continuous domain range. So yesterday we looked at discrete. Discrete was functions where we just had certain points, okay? So go ahead, you'll see my video here. So underneath the video, you're going to click load continuous domain range in a new window. And we're going to use Cami again. If you have issues with this opening, then please send me an email, okay? Don't get a 0 just because you're not doing it. Send me an email, let me know. Okay, so continuous is the difference between continuous and discrete is continuous means that we're like the line's continuing, means it's connected, everything's connected. So here we have these two endpoints, but we see this line all the way in between it. So all these points are connected. Every single point on this line is part of the line, right? It's inside this function. But the points are connected. There's lines all the way across. But yesterday when we were looking at graphs, when we were taking domain range from the graphs, we just had individual points. They weren't connected. They weren't drawn together. So we just looked at the x values for each of those points because there wasn't anything else in between them. Today, we're looking at all of these x values. So we're thinking about all the possible numbers we have for our domain for x and all the possible numbers we have for the y. Okay, so the first thing I want to do is come up here and I'm going to change it's red. Okay, I'm going to say domain is our x values or input. Okay, same thing as yesterday. We have the same definition for domain range. Range is the y values or the output. So x is the thing we're putting in, y is the thing we're getting out. When we're looking at a graph, our x values come from this axis and our y values come from this axis. So when we're looking at graphs, we want to find domain from left to right. Do this little arrow. You can do this little arrow by doing the dash and then the greater than symbol. So left to right. And for range, we're going to look at our values because left to right means if I start on the left-hand side, I'm looking at the x value for this side. Right means I'm looking at the x value for this side. And then the y values, we're going the lowest number to the highest number. So on the range, we're going from bottom to top. So left to right is domain, bottom to top is range. I'm going to show you what I mean, okay? So for domain, we're looking left to right. So I'm going to go to the furthest point left that my graph goes. So on this one, it's right here. This is the furthest left. And I'm going to draw a line down to see what is my x value at that point. Well, it's -4. So I'm going to write -4. And when we're writing domain, we like to write it, domain range, we're going to write it in inequality notation. So inequality means that we're going to use less than or equal to or greater than or equal to symbols. And if we always write left to right and bottom to top, then our symbols will always be a less than. So we're going to have -4 and it's going to be less than, always a less than. And I'm going to say that it's equal to. Do you guys know why I'm saying it's equal to? Because this dot right here is a closed circle. You see over here, this one's open, so we're not going to have equal to over here. Here we're having an equal to because it's closed. Okay, so we have -4, less than or equal to. We're talking about x values with our domain. I'm going to do another less than or equal to symbol, and I'm going to go to the furthest right that my graph goes. So here's the furthest point right I go. I'm going to draw a line up, and it goes to +4. So 4 is the biggest. So what this means is all of my x values, any point on this line, the x value for any point on the line is in between the numbers -4 and +4. So what I'm saying is all of my x values are in this range. So every single number, every single, even little tiny decimal that I can't even like compute, that I can't even say the numbers to or whatever, even every tiny decimal in between -4 and +4 is part of my domain. Every single number, okay? So we consider all of the things in between -4 and +4 to be part of my domain because my line never stops. There's not a gap anywhere. So every single, even little tiny decimal, little tiny number, as close to 0 as you can possibly get is part of my domain, okay? So my range, I'm going to change colors here. I'm going to start at the bottom point on my graph. So this is the lowest point here. And I'm going to look at my y value. Range is y value. So I'm going to go -3. As long as I go bottom to top, it's always a less than. We're going to have equal to here because it's a closed circle. We're talking about y's. And then I'm going to have another less than or equal to because the top point is closed. So up here, I'm going to come to the very top of my line. And my y value here is +3. Okay, so domain, we're going left to right. Range, we're going bottom to top. So number 2, I'm going to go left to right for my domain. So the furthest left my point goes is right here. I'm looking to see what is my x value. So my smallest x value is -3. Since I'm going left to right, I can always do less than. Oops, I don't want equal to because this is an open circle. It's not equal to, it's open. We're talking about x values. I'm going to do another less than, and I'm coming to the furthest right. It's open, so I'm going to leave that as just less than. It's not going to be equal to. So the furthest right I go is right here, and my x value here is +3. Okay, domain, we're going bottom to top. So the lowest point on my graph, I'm going to come over. I'm going to look at my y value there. My y value is -5. It's less than, no equal to because it's an open circle. Talking about y's, so it's a y there. Another less than, it's going to be, my top point is open as well, so I'm going to leave that as just less than, no equal to. So my top point, I'm going to come over and see what my y value is here. Well, it is +3. So my domain goes from -3 to 3. My range goes from -5 to 3. Okay. So number 3, let's look at domain. We're going to go left to right. So my leftmost point here, this is the furthest left my graph goes. Starting there, I'm going to look at my x value. So my x value is -4. We're going to go less than, that's a closed circle, so I'm going to have equal to. X is less than or equal to, I'm going to go ahead and put an equal to because I see a closed circle over here on this side. The furthest right I go is right here, and my x value is +3. My range, I go bottom to top. So I'm not looking at just these two endpoints. I'm going from the very bottom of my graph. So the lowest my graph goes is right here. And my y value here is -5. This is a solid line, so that means it's equal to. Solid line is just like a closed circle. If it was open, if it was not equal to, we would have a dashed line, okay? Is y, and then we're going to go less than or equal to, and the very top of my graph, it's the same on both sides, right? So the very top of my graph is +4. So we're going lowest point on the graph to the highest point on the graph. All right, so number 4, we're going to go left to right for domain. So leftmost point is right here. Coming up, my x value is -4. This is less than, I'm going to leave it as just less than because it's an open circle. Coming to the rightmost point, my x value here is 5. Oops, I have x is less than. This is open again, so I'm going to leave that as less than 5. All right, then we have range. We're going to go lowest point to highest point. So here's my lowest point. My lowest point here is -3 on the y-axis, so -3 less than y. This is an open circle. Less than, now I'm going to go to the highest point on my graph, the highest place on my graph, on my line. This is not the highest place. If I cut my domain off, my range off right here, then I'm forgetting about all of this up here, okay? So I want to come all the way to the highest point, all the way up here. My y value here is positive 3. And up here, this is a closed line, a solid line. Because it's solid, I'm going to make this equal to. Okay? So I want you guys to try number 5 and submit that. I want you guys to do 5 and 6. So let's look at number 7. Number 7, for domain, we're going left to right. So here's my furthest left. And over here, I noticed that this has an arrow. Because I have an arrow, this is going to keep going forever and ever and ever and ever, right? That's what that means. It means it's never going to stop. So I don't have a leftmost point. So then I'm going to come to the right. Well, on the right, I have an arrow too. So that means it's going to keep going forever and ever and ever in that direction. So I don't have a rightmost point. So this line is never going to stop. So I'm always going to be able to have an x value. If I go all the way out on my x-axis to negative 552, I'll be able to reach up at some point and touch that line. Or if I go all the way out to negative 1 billion, I'll be able to reach down. We'll be able to reach down at some point and touch that line. If I go all the way out to positive 1 billion, I will be able to reach up at some point and touch that line because this line is never going to stop. So what we say here is this is all real. Let me just type this because that looks terrible. I'll do purple so it's at least close. Okay, so here when we have arrows on both ends, we say this is all real numbers. All real numbers. So is it any different from my y-axis? My y from bottom, the lowest point, there's an arrow again, so it's going to keep going. It's going to keep going forever and ever and ever down. And there's an arrow on the top. It's going to keep going forever and ever and ever and up. So we would say the same thing for our range, all real numbers. Okay? So if you're looking left to right and you have arrows on both ends, then you say all real numbers. If you're looking bottom to top, you have arrows on both ends, and then you say all real numbers again. Okay, so over here on number 8, we're going to go left to right. So here's left. I hit an, oops, let me go back to my purple color so we're consistent. Okay, on the left, I have an arrow, and on the right, I have an arrow. So I'm going to say all real numbers, and I'm just going to write ARN, all real numbers. You can type in all real numbers if you want, okay? So the range, we're going bottom to top. So down here on the bottom, I've got 2 arrows, so it's never going to stop going down. So I don't have a bottom to my graph. But I do have a top. So up here, the top of my graph stops at 4. So that means I have y is less than or equal to, because it's a solid line, positive 4. So I don't have anything on this side of my y because it's going to keep going down forever and ever and ever. So here we're saying that all my y values are smaller than 4. And we're talking about all of the numbers that are smaller than 4. Every number that's smaller than 4 is going to be on this line. It's going to be part of this line, okay? Okay, so I want you guys to do number 9. I want you to do number 5, 6, and 9, and make sure you submit it. All right, let me know if you have any questions.